let's go back to the application of derivatives to problems in economics. In this one, we have marginal revenue. Say someone is selling custom-made office desks. Now the revenue earned from selling X number of such desks is given by this formula. This many dollars will be earned if X such desks are produced and sold. We then have to calculate in this first part the marginal revenue when X desks are produced and sold. So you know what that is. It is the derivative of R of X with respect to X. So what will you get if you differentiate R with respect to X? 2000 of course is constant. Differentiating 1 you will get 0, and differentiating this using chain rule you will get 1 divided by 1 plus x square. So that is the marginal revenue. So the marginal revenue is this many dollars. If X such desks are produced and sold. In part B, we have this, where we have to use that R prime of X, that derivative function, to estimate the increase in revenue that will result from increasing the production from 5 such desks per week to 6 such desks per week. That is, if one more item is produced and that is also sold, then the extra income, in fact that is the marginal revenue. So we have to estimate that from this, which means that we have to calculate R prime at the point x equal to 5. And the value we roughly get is this. Is approximately $55.56. So you can see, you calculate yourself, R prime of x is available 2000 divided by the square of 1 plus x. There you put x equal to 5 and you do the calculation, you will get this figure. Finally, this is part C. In part C, we have to find the limit of this derivative as x approaches infinity. And then we have to interpret that limit, that number. So let's go back to what R prime of x is. We straight away write the limit. So you can see clearly that this is 0. Now how do we interpret this 0 limit? The 0 limit is this. The above limit indicates that the marginal revenue from selling X desks gradually vanishes as X tends to infinity, which if we want to elaborate it a little more, this means that say someone produces X such desks, and by selling those desks he earns some money. If one more disc is produced and that is also sold, then he earns an extra amount of money. That is the marginal revenue. However, if the number of discs produced itself becomes larger and larger, then this amount of marginal revenue goes down and gradually vanishes. Okay, so that is the interpretation of this limit. Okay, next we have some additional applications. Let's see this 128th one. The number of gallons of water in a tank t minutes after the tank has started to drain is given by this formula. Q of t equals 200 times square of 30 minus t. Then we have to say how fast is the water running out at the end of 10 minutes and what is the average rate at which the water flows out during the first 10 minutes. That means we have to find the instantaneous rate as well as the average rate. So the instantaneous rate is obtained by differentiating q of t with respect to t and evaluating that derivative at t equal to 10. Okay, so this is what it is. You can write the line that this is the rate at which water goes out. You can write those things. I am just simply going to calculate this at t equal to 10. So if we differentiate this with respect to t, what shall we get? This 2 will come down and will get multiplied with 200. So that will give us 400 times 30 minus t. But at the same time, because we are using the chain rule, we have to differentiate not just this power but 30 minus t separately. And that gives us minus 1. So there will be a minus here. And this you have to evaluate at t equal to 10. So that means 30 minus 10 will be 20. When you multiply that with this, you get minus 8,000 gallons per minute. Okay, so that is the instantaneous rate at which the water is going out when t is equal to 10 minutes. Also, the average rate is going to be, of course, you know what it will be, q of 10 minus q of 0 divided by 10 minus 0. And if you do the calculation, you will get minus 10,000 gallons per minute. Okay, so these are the things. Okay, this next one is about volcanic lava fountains. There was an explosion in 1959 in the island of Hawaii. A volcanic eruption was there, and during that, from some vent, from some lava vent, lava was shot up straight into the air and it reached the height of 1900 feet. It's the world record. So we have to find the exit velocity of lava in feet per second and also in miles per hour. If this maximum height reached by lava is given to us. So let's see how it can be done. So we can start the solution like this. If V naught feet per second is the exit velocity of lava, then the height reached after t seconds, you can write simply as EC, is S equals V naught t minus 16 t square. So, using this equation, we can find the velocity of lava at any point of time, which is this ds dt, and that is equal to 32t. Now, what happens when something is thrown up and it reaches its maximum height? What can you say about the velocity at that instant? We have already seen this before in other problems, that at that instant velocity is 0. So, this is the condition at that maximum height 1900 feet, which means that we have this, or t equals V naught divided by 32. So, the time taken to reach that maximum height, it depends on the exit velocity V naught, which however we don't really know. Okay. So, we have to, this is where we have to stop. However, we will now use this back in this equation, and that should give us the height, maximum height reached. So, if this many seconds elapsed after the lava exited the vent, then at that instant it should have reached 1900 feet, and that 1900 is given to us. Hence, let me write this expression on the left hand side. When you make the substitution, t equal to V naught divided by 3. Divided by 32, sorry, minus 16 times V naught square divided by 32 square. This should be equal to 1900. And then you can clearly see that this will be a quadratic equation in V naught, which however luckily has only V naught square. There is no V naught term. So, solving it should be easy, and if you do that, you get this approximate value of V naught, which is 348.71 feet per second, or if you convert this into miles per hour, then you get 237.76 miles per hour. You please go through the details of the calculation and check if these figures are correct. Okay, if not, then write in the comment section below, because this type of things should, we should not keep any errors here. But this is what it is. So, with this actually the exercises end. There are others, of course. For example, the ones that I have not solved, and after this you have this graphing exercises, which however are always left to you, because you have to use a grapher, a graphing calculator. But besides these things, we have done whatever we had to do, and this section ends. After this, in the next section, we have derivatives of trigonometric functions that we will start next week. So that will be all for tonight in calculus. See you tomorrow with a new upload. Until then, this is me, Lucifer from A Mathematical Room. Have a nice day.